Namaste. Today I will explain the second experiment of DSP Lab, that is to implement linear and circular convolution of two sequences. Now, before writing a program for linear convolution, let us see what is an convolution. So, convolution is an integral concatenation of two sequences. In order to perform a convolution, minimum you need to have two different sequences. By considering those two sequences, easily we can do the convolution operation on them. What is the application of convolution? Convolution application is, it has been widely used in the signal processing applications and majorly it is used to get a time invariant output by convolving an input signal with the impulse response. Now with this I will write an equation for convolution, that is a linear convolution. You can write an equation as y of n is equal to x of n convolved with h of n. So here I have considered two sequences x of n and h of n, and the output has been assigned to a y of n. If you expand this equation, you can write this equation as summation k is equal to minus infinity to plus infinity x of n into h of n minus k. So, this is an equation for linear convolution. Now, by substituting the values for this equation, we can get an output of linear convolution. For this, let us consider any two sequences x of n is equal to, you can choose any values for these sequence. I will go for 1, 2, 3, 4. So, this is a first input x of n. Then I will take a second sequence h of n. So, you can consider here also any value. I will take the value as 3, 2, 1. So, these are the two considered sequences in order to get a linear convolved output. Now, let us substitute these values into the linear convolution equation. Before that, what is the output length of a linear convolution? Output length is always equal to, in case of linear convolution, length of first sequence, which I have considered as x of n, plus length of second sequence h of n minus 1. So, this is an output length in case of linear convolution. What is the length of x of n? See here, how many values are there? 1, 2, 3, 4. It is 4. Then plus, what is the length of h of n? It is having only 3 values, 1, 2, 3. 3 minus 1. 4 plus 3 is 7 minus 1 is 6. Now the output length is 6, where you can write this value for n as n is equal to 0, 1, 2, 3, 4, 5. Totally there are 6 values which are ranging from 0 to 5. Okay. So, this is an output length. Now, how to solve this equation with respect to x and h? First, let us solve this equation. Y of n, write it. y of n equals summation k is equal to, it is an infinite length sequence, but here you need to go for a maximum length considered value. See here, what is the maximum value between x and h? It is x, which is having 4 values. So now you can write it as summation. 4 can be written as 0 to 3. K is equal to 0 to 3. Write the sequence as it is. X of n, h of n minus k. Now, first let us expand this equation for n different values, which is ranging from 0 to 5. Put n is equal to 0. If you put n is equal to 0 here, what is the value you are going to get? Y of 0 is equal to k is equal to 0 to 3 x of 0 into h of n value is 0. I have considered 0 minus k. First substitute n value, then try to expand the equation for k values. Now expand it for k values. X of 0 into h of 0 minus, what is the first value of k? It is 0. Since we have a summation, put plus. X of 0 into h of 0 minus, what is the second value of k? It is 1. So k is 0, 1, 2, 3. It is ranging from 0 to 3, that is 0 to 1, 0, 1, 2. Plus second one, x of 0, h of, what is the second value? 0 minus 2. It is 0 to 3. 0 to 3 means 0, 1, 2, 3 you have to consider. And go for a last value plus x of 0, h of 0 minus k last value is 3. We have expanded this equation for different values of k, 0, 1, 2, 3. Try to simplify this value in order to get a first output value. What is x of 0? So see, this you can take it as x of 0, x of 1, x of 2, x of 3. The same way, this will be considered as h of 0, h of 1, h of 2. What is x of 0? The first value is 1. 1 into h of 0. What is h of 0? It is 3. Plus x of 0, again it is 1 into h of minus 1. So see here, do we have any negative values with respect to h? No. We have started only at h of 0. If we don't have a value for h of minus 1, directly make this value as 0. 0 into anything, that is with respect to 1, its value will be equal to 0. Plus, here also we have h of minus 2. What is minus 2 value here? We don't have a value, hence you can take it as 0. 0 into anything, it will be 0. Here also, h of minus 3 is 0 and 0 into x of 0 value will be 0. And after solving this, we got an final first output of y as 1 into 3, that is 3. Okay. So similarly, you need to solve this equation for all the n values starting from 0, 1, 2, 3, 4, 5. So still you need to solve this up to y of 5. So this is an solving a linear equation of two sequences. So after solving this, now let us try to write a program for the linear convolution between the two different sequences. Now let us see how to write a program for linear convolution. So just now we have seen that how to solve a linear convolution using an equation. Now to write a program. So in the beginning class itself I have told you what is the very beginning line you need to use on Matlab. That is CLC. So it is used to clear the window. Along with this you need to use clear all also. Now we know that for a convolution we need two sequences which we have considered as XH. And what is the output? It is Y. First, for any program you need to enter what is the input of the program. So what is the input? X and H are the inputs. X is equal to, in order to write a input function in a Matlab, we have a command called input. Input of, open the bracket. Within a single inverted code, you can write enter the first sequence. Okay, so through the input you can enter the first sequence, or else you can also avoid this input function. You can directly enter the sequence 1, 2, 3, 4 like that within a square bracket. So preferably try to enter the input through this input function of a Matlab. Then we have a second input of linear convolution. It is a H, and again I'll write the next line as input. Enter the second sequence. Close the single inverted comma and give the semicolon. Then after entering these two inputs, now you need to perform a linear convolution on these two inputs. For a linear convolution in a Matlab, we have a function called conv. This is a Matlab function which is used to perform the linear convolution between two sequences. Conv of, what are the two inputs we have taken? It is X, H. You can change the variables. You can go for X1, X2, etc. Okay. So whatever the input you have entered, that has to be inside the convolution function. Then what is the output we have taken? It is a Y. So assign it to a variable Y. Now the linear convolution output is stored in Y. You can display this output on a command window. How to display that? Use a Matlab command disp. Within a disp, within a single inverted comma, you can enter the text. The linear convolution output is, okay, if you write only this sentence will be displayed on the command window. But I need a value of linear convolution. Where it has been stored? It is stored in Y. Now I'll give disp of Y. Okay, at this end, along with the text, we are going to get the values of linear convolution. So this is to display the output. Now, how to plot this output on the figure window? So as I have shown you the figure window in the first program, here also you need to display this output on the figure window. For that, we have a Matlab function called stem or plot. If you need to go for a continuous way, go for a plot. If you want a discrete waveform, then use stem. Before using stem, you need to define what is the length of the output. Length is generally assigned to a small n. Okay, whereas to the values need to start, it has to start at 0th position. So it will be like this. If this is a figure window, n will take a different values like 1, 2, 3, etc. And at the origin itself, we need to get the output. Hence, it has to 0, 2, give a colon. What is the length of this output, complete output? It is equal to y. Y is nothing but, as we know, it is counted as 1 to 6. Suppose if you have an n value as 7, then this can be counted as 0 to 6. Then you need to subtract the complete output by 1. How to subtract that? 0 to length of y. Whatever the output we are going to get, that length of y minus 1. This is an output length. It has to start from 0, where it has to end. Whatever the maximum length of the output we are going to get, that has to be subtracted by 1 since it is starting from 0. Now, plot this on a figure window. Since I need a discrete value, I'll use stem. For stem or a plot function, the x-axis value should be entered first. What is the x-axis value? It is a n value. N comma. What is the output? It is assigned to y. Then you should enter output. Give a semicolon. So now the output is displayed on the figure window. As from the calculation, we know that at n is equal to 0, what is the output we got? We got an value which is equal to 3. So this will be continued. And here it always shows the n values, and this will be the output magnitude. Next, you can give what is x-axis, what is y-axis, and what is the title of the program. So it will be displayed over here in the figure window. How to give that? We have a Matlab command called xlabel. So here within a single inverted code, give. So what is we are having here? It is a n value. Can give that. And we have a y label. What is y-axis is having? It is nothing but a magnitude or an amplitude. So give it as magnitude. Next, give a title for this program. What is the title of this program? So it is a linear convolution. It is a linear convolution. So if you end this, now the complete program for linear convolution is ready. So you need to give the proper input entry, then you need to define what is the output length, then you need to plot that output on a figure window. Also you can give the title and x-axis and y-axis parameters for the figure window. Students, now I'll show how to execute linear convolution program in a Matlab. So you know the Matlab icon, click on it. So when you double click on the Matlab, you'll get a window like this. Okay. So now
every time you need to select a new script, that is a new file to type a program. Go to new script. So now you got a editor window here, command window, and this is a workspace. Now in the editor window, you need to type a program. Just paste the program now, which is of linear convolution of two sequences. So this is a code we have written. Since we have written the code for this linear convolution with the input function, so you need to enter the input after running this program. So once you type the program, you need to save this program. So you know that how to save a Matlab file with the .m extension, you need to save the program. I'll go to save. In any drive, create your folder with your name or USN number, then save the file. Preferably, I've created my folder in desktop. So I've used a desktop here. I have my file here within this folder. I'm going to save the linear convolution program. So while saving a program, you need to very much clear about what is the name you're going to give for the program. Never give the Matlab command as a program name. I'll give it as linear convolution 1.m. Save. So after saving the program, you need to run this program to check for the errors. So if you don't have any errors, directly it will ask for the input sequences entry. Now I'll run this program. I'll give change folder. Now see here. So now we have executed this program. There is no errors in this program. Hence, we got a sentence in the command window. Whatever we have written inside the input command in the program, it is displaying in the command window. Now, give the sequence. While entering the sequence, you need to enter it within the square bracket. Open the square bracket, give the sequence. I'll give 1, 2. Either you can give the comma in between the values or you can give the space. 3 space 4. I'll close the bracket. Now I'll press enter. If you press enter, it will ask for the second sequence. See here, now we got the second input statement, that is enter the second sequence in the command window. I'll type 2, 3, 4. Close the bracket. Now if you press on enter, you'll get the convolution output. See here. Within a display function, what you have written, that will be displayed first. The linear convolution of sequence is, so now it is displaying that. Then you're going to get output values because we have given disp y here. Y is the output and these are the output values we are getting. Now, after seeing these values, you need to see the output of these values on the figure window also. So this is what a figure window we are getting here. See here at the 0th position, we are getting a value 2. Then 1 position at a 7, like that. The values has been displayed in the figure window. And whatever the X label and Y label title we have given, that is also displaying here. In the X label, we have typed time. So it is showing time. Then in a Y label, magnitude. Then the title is linear convolution. So in this way, you need to see the output of the program. Thank you.
Now I'll explain the next part of a second experiment, that is circular convolution. Here also, before going into the programming of circular convolution, let us see how to solve a circular convolution. Here also, since it is a convolution operation, we need to have two sequences. Have considered two sequences called x1 1 1 2 1 and x2 1 2 3 4. Both are of length 4. Here also we have a 4 values and here also it is 4. Now what is an equation for circular convolution? It is again having two inputs and one output. Output is assigned to y of n and summation you can give any variable here. I have used small m. M is equal to 0 to capital N minus 1. x1 of m into x2 of n minus m with the mod function capital N. Here you need to know what is this capital N. Capital N is a length of output. Okay. Now how to get a length of the output in the case of circular convolution? So in the circular convolution, the output length will be, that is capital N will be maximum length of, is max of the output length of first input, comma output length of second input. What is the maximum value? In the length of x1, it is equal to 4 since it is having 4 values, right? 4. Comma. Then in the second sequence also we have got 4 values, enter 4. What is the maximum of 4 comma 4? Obviously it will be equal to 4. Then the output length is equal to 4. If we go for an unequal length sequence, so let us assume that we have a first sequence of length 5 and a second sequence with the length 4 itself. Now, what is the maximum value of 5, 4? It is 5. The output length of a circular convolution in this particular case, it will be equal to 5. Now, how to solve this equation for a different values? Since capital N value is 5, as output length is 5, small n, that is a length can be separated to a different values like starting from 0, 0, 1, 2, 3, 4. It is having 5 different values ranging from 0 to 4. But these n discrete values, try to simplify this equation. Now, put n is equal to 0 in the first case. Y of 0 is equal to summation m is equal to 0. As for this condition, just now we have calculated what is capital N we got. Both are of equal length and capital N value will be equal to 4. M is equal to 0 to N. N is 4. 4 minus 1 is 3. And 0 to 3. x1 of m into x2 of n. What is n? For the first case, it is equal to 0 minus m with a mod function capital N. What is capital N? It is equal to 4. Now, expand this equation for different values of m. Summation, expanding this equation, x1 of what is first value for m? 0 into x2 of 0 minus m is also 0 with 4 mod plus. Then go for the second value, x1 of 1, x2 of 0 minus 1 with 4 plus x1 of 2, x2 of 0 minus 2 with 4 plus the last value x1 of 3 into x2 of 0 minus 3 with the mod function 4. What is x1 of 0? As I told you, so you can rewrite this as x1 of 0, 1, 2, 3. And similarly, x2 of 0, 1, 2, 3 position values. What is x1 of 0? In a 0th position, we have a value 1 into x2 of 0 minus 0, it is 0 itself. Here, no need to use this mod function value since it is having a value of 0th position. x2 of 0 is 1, write 1, plus x1 of 1 in a first position, we have 1 value here, use 1 into x2 of 0 minus 1. So, it is nothing but x2 of minus 1. Do we have any negative values here? No, we don't have it. Hence, use a mod function. x2 of minus 1 is nothing but x2 of 4 minus 1. You can rewrite this as x2 of 3 plus x1 of 2. x1 of 2, next position value is 2 into x2 of 0 minus 2. Here also we got a negative value. Subtract it from 4. 4 minus 2 is 2. x2 of 2 plus x1 of 3 is, it is equal to 1 again. Use 1 into x2 of minus 3. Again subtract it from 4. 4 minus 3 is 1. x2 of 1. Now we got these values. Now substitute it. 1 plus 1 into x2 of 3, it is 4, plus 2 into x2 of 2, 3, plus 1 into x2 of 1, it is equal to x2 of 1 is 2. Substitute it. So it is equal to 1, 4 into 1, 4, plus 3 into 2, 6, plus 2 into 1, 1. Finally, we are going to get a value as 10, 12. Y of 0 value is after simplification 12. So, this is the first output we are going to get after writing the program in the Matlab also. So, in this way, you need to solve this complete equation for different values of n, small n. So, it is having 4 values. So, n. For 0, we have done the calculation. Repeat it for n is equal to 1, n is equal to 2, and then n is equal to 3. So, with this simplification, now I will explain how will be the programming of circular convolution of 2 sequences. Now, I will explain how to write a program for circular convolution. So, as we know that you need to start every program of a Matlab with clear, that is CLC, and clear all. Then, as we know, here also for a circular convolution, we have considered 2 sequences, x1 and x2. x1 is equal to x2 is equal to. How to enter these 2 sequences? Again through the input within a single inverted quote, right? Enter the first sequence. Then, similar to that, go for a second input which is assigned to a x2 input of enter the second sequence. Now, how to get length of this output of a circular convolution? Before going to get an output length of circular convolution, let us add the length of x1, x2 to the other variables. I'll take n1 is equal to length of x1, n2 is equal to length of x2. So now N1, N2 are the lengths of X1 and X2. What is the output length of circular convolution? It is always denoted by capital N. What is capital N? As I told you, it is a maximum value of the lengths of the two considered inputs. Where is the length now? It is there in N1, N2. So it is maximum of N1, N2, which is equal to N. Now this is an output. Next, how to consider the given sequences with different lengths. Suppose if we have a first sequence X1 with three different values, 1, 2, 3, 4 like that. Then the second with only 3 values, 3, 2, 1. Now these two are unequal length sequences. For these two unequal length sequences, you need to make these two with the same length. How to make these two sequences with the same length? By adding 0 into the second sequences. If you add 0 to the X2, then the lengths are equal now. Suppose if you consider the first one with only 2 values and the last one second sequence with 3 values. Then now you need to add a 0 to the first sequence. Okay. For unequal length considered sequences also, you can make the lengths equal by adding. We call it as a zero padding. That is adding zeros to the sequence. Now how to add the 0 to the sequence? That is by considering a difference between the lengths. Now what is the difference between the lengths? It is N1 minus N2. I'll assign it to the another variable called N3. If N3 is greater than 0. N3 is greater than 0 means for this sequence, see here, X1 with 2 values, X2 with 3 values. Now, if we subtract 2 minus 3, what is the difference we are going to get? It is minus 1. Is minus 1 is greater than 0? No, it is less than 0. Wherever you get a difference as less than 0, it is understood that the first sequence is having lesser value compared to a second sequence. In that case, you need to add a zeros into the first sequence. Then, let us go for another condition where we have here the 4 values, the first sequence. And in the second sequence, we have only 3 values. Now, subtract 4 minus 3. What is the answer we are going to get? It is 1. What is 1? It is a greater value than 0. Wherever you get a value greater than 0, that is understood that the second sequence is having lesser value. You need to add a zeros into the second sequence. Now, if you have N3 greater than 0, it is understood that the second sequence is having less value. Add 0 into the second sequence. X2 is equal to X2 comma zeros. To add a zeros, we have a Matlab function called zeros within a square bracket. You need to write 1 comma. What is the value? Difference has been assigned to N3. If you get here how many zeros you need to add, difference is 1. Like that, it should be given to N3. Okay. Now, let us understand the second case of this particular condition. Else, Since we have used if function, you need to give one more condition using else. Now, if n3 is less than 0, what has to be done now? Here, it understood that if n3 is less than 0, the second sequence is bigger compared to the first sequence in respect to values. Since it is minus 1, it should be added to a first sequence x1. So, here write x1 is equal to x1 comma zeros of 1 comma negative value should be added. So, you can take it as minus n3. So, this is a condition of padding zeros to the given sequences in the case of unequal length based on the difference. Now, after this, now you can go for displaying the values with respect to the output. How to write an output? So, before writing an output, see here in the equation of circular convolution, we have variables. What are the variables? Capital N. So, it's been already defined. It is a maximum length of n1 comma n2. Then we have small m and small n. So, it will be having always a length equal to capital N itself. I'll define small n as it is 1 to capital N. Otherwise, you can write it as 0 to n minus 1. That is also correct. Then, small m with 1 to with a colon capital N. So, these are the limits being used for a equation of circular convolution. Now, write a output equation y. So, since here we have a summation function, it is an accumulation process. Each time the added values will be accumulated. So, since it has been accumulation operation, you need to initialize the initial value of y to a 0 in order to avoid a garbage value consideration. Now, I'll take y as 0. Initially, it has been assigned to a 0th value. Then, write the output equation. Y is equal to, what is the equation we have? Write it. X, equation considered, x1 of m into, you can write what we have here, it is a x2 of, it is having mod function. So, within that, mod of n minus m into capital N. Then use comma 1. For this whole equation also, you can use a bracket term. So, this is an equation written for the circular convolution. With this, the output is stored in y. Now, the circular convolution output can be displayed using a DSP function, DSP of circular convolution output is DSP of y. We got a command window output values. Now, how to plot it on a figure window? As we know, to plot it on a figure window, first you need to define the length of the figure. So, give it to again 0. From where it has to start? It has to start from 0. N is equal to 0, 2. Where it has to end? The maximum value of output n minus 1. Since it is taking a value from 0, it has to end at n minus 1 value. Now, give a stem. Since I need a discrete values. How to give stem? First use x-axis value small n, then go for a output y. here also you can give X label within a single inverted code, it is n value, and Y label within a single inverted code, it is a magnitude, and give a title, that is circular convolution. So this is a program for a circular convolution where you can verify the results which is solved by the equation method, and you can also see the figure with respect to the discrete values in the figure window of the Matlab. Thank you.
Now, I'll show you how to execute circular convolution program in a Matlab. Double click on the Matlab icon. Then you'll get a command window, but you need to type a program in editor window. So select new script. So in an editor window, type a program. After typing a program, you have to save this program. Save the file in your folder. Give the name here in the file name. So I'll give it as circular convolution 2.m. Say .ms mandatory extension for Matlab file. After saving the program, you need to run this program. Click on run. Give change folder. Enter the sequence within a square bracket, either by giving comma or space. Now we got a circular convolution output as 22, 24, 30, 24. Within the DSP function, whatever we have typed, that is displayed here. The circular convolution of two sequences is, the value has been showed. You can also see the output in the figure window. And these are the different values what we got in the circular convolution with X label, Y label and title. Thank you.